same time that as him. So this, it's a service. It can eventually start attracting real users. So, and for the end user, it shouldn't really matter where the service is running, whether it's running on the internet, whether it's running in GENI. So you can imagine that, like, the real users just have an app on their phone, and while they're using this application, that will use the service that is deployed on GENI, or they can have, like, as it says here, slice 0 is the internet. So GENI is not envisioned to replace the internet. It's just to have like a parallel infrastructure so that people can test more stuff, and coexist with the internet at the same time. So, and at the end, the experimenter published a lot of papers, started a startup, become very rich, whatever. There is a full service that now is being deployed, and people can start thinking about, transitioning this to the internet, or, he can lead and running it in GENI. And then, we have all these people that now they want to use the service. So this is just kind of a motivating example of how the research in GENI is supposed to be done and how it's supposed to transition. So it's the idea that it will support large-scale experiments. You can run services on GENI, and you can have like real users actually using the service. So, this was his idea. He did his experiment. Other people might have other ideas. If you have an idea about how to use such a test bed, there are opportunities in NSF. There is funding through NSF in order to test your ideas in GENI. Now, so I said this story just to give you like what is GENI supposed to support in terms of experiments. So one thing is at-scale experiments. It's a thing that we couldn't do before we had such large test beds. You have like a few computers in your lab, and that was it. So GENI is meant to enable at-scale research that are actually in wide area networks. It's supposed, of course, to support internet-incompatible experiments, so that people that want to innovate and go beyond what we have now and test new ideas, they should be able to do this in GENI. They should be able to do both repeatable, the small type of experiment that I described before, but also in the wild experiment. So what will happen is, if I grow the number of the computer in my slides, like hundreds of nodes. It should have support for opt-in real users, so that people running experiments can actually get real traffic within their slides and see what will happen there. And it also should make it easier to instrument, orchestrate the experiments, because suddenly when you move to large-scale experiments, suddenly it's very challenging to actually manage and measure your resources, because it's all the computers are not anymore in your lab that you can go and actually like do stuff and debug there. So we need good instrumentation and measurement tools. So the idea is that all is to a little bit break the ceiling of networking research and give the opportunity to people to test new ideas that they weren't able to do before. So how we would go about building GENI, right? This is a very ambitious project. How we would go about creating such a nation-wide test bed. So the basic thing is that GENI is a federation. If you start building GENI from the beginning, like start building parallel infrastructure with the internet, it's very expensive, very time-consuming. It will not. It's not feasible to start building from scratch and build infrastructure that is parallel to the current internet. So the idea is that we will GENI enable existing resources, existing networks, existing test beds, and it's going to be a federation that everyone that wants to participate in GENI, they're going to offer the resources and connect them to the GENI network. If you think about it, this is very, very similar to how the internet is built. Internet is also a federation of different administrative domains. Everybody's own equipment and building, and they built this giant network. So the experimenter will be able to get resources in networks, in GENI resources like the GENI racks, in campuses around the US, in regionals, in other type of test beds, and you can imagine their slides also expanding to commercial clouds, like include other type of industry resources. This way, first of all, we avoid technology locking. So when during the original stage of designing, if you don't make exact choices about how you're going to build, but you're just going to federate and allow people, to bring in their own resources, there is no technology that you're actually logging yourself in, and you can just incorporate any future technologies, any future test beds that are going to come out of it. And there is also the ability of growing very quickly because it's a distributed federation. There is no central authority. So this is the current GENI footprint. You see, all the small dots are places where we have what I call GENI racks. I'm going to talk about them in more details. The small triangles is where we have mining space stations. So we have about only the mining resources, and you can see exactly where they are. And you see, this is the GENI network. You see that it follows the GENI, the international backbone of Internet 2. And these are the network infrastructure that is also incorporated within the GENI network. Now, how did we build it at sufficient scale? This is like a more specific example. So you start by existing equipment that is already there, and you just what we call GENI enabled. I'm going to talk at the end about what exactly GENI enabled means, but you can imagine that it's a thin layer, mostly of software, that allows this resource to have the two basic principles I talked in the beginning. It allows it to be sliced and shared among multiple experimenters, and it allows the programmability for running experiments. And basically, that is what it means to GENI enable existing equipment. You will deploy it in campuses, so you will start by GENI enabling universities across the US. And then, as you start GENI enabling them and connecting them through the research platforms, you start building, at scale events, and you start building like a large scale prototype. So let me talk a little bit more about the GENI architecture. So I said that you started with a campus, so you can imagine within a university you have you may have like a GENI rack, which will be your main connectivity. You might have like wireless resources, or you might have other resources that you have in your campus, other type of unique resources, like people have connected telescopes into GENI, or I don't know, people wanted to bring like the grid inside, but whatever they have and they think it will be useful for the research, they can connect it to the GENI. This, you see here the orange lines are what we call the GENI backbone. This is the GENI network, right? And all of the resources also have connectivity to the real internet, to the public internet, and this is what we call the control plane, which is basically how experimenters get to control the resources. Because since this is remote experimentation, all the experimenters need a way to be able to actually go into the resources, log in, and modify them. Now, for all the campuses, they connect directly to a regional network, and there, they have like this layer 2 GENI network connectivity, and in the regionals, you might also have other GENI type of resources, whether are GENI racks or GENI switches that go through the path, and they also have, the normal control plane as well, so that people can control any type of GENI resources that are within the regional. And of course, then we go to the backbone. So these are the research backbone. You can imagine here Internet 2, for example, that has already deployed GENI-enabled switches in their backbone and gave access to experimenters. And from there, you can imagine going all the way to homes and local communities by GENI-enabled equipment if you want to bring in real opt-in users. And again, all these resources are connected to the control plane for experimenters to be able to control the resources. So let's go to a very concrete example, and I know it's not fun to look at networking maps, so I'll try just to point some stuff out. This is the network map of the Wisconsin campus. So you see here they have the GENI rack, and they have connected to the GENI rack two different labs they have on the university. One is the lab of Parmesh Ramanathan, that is a PI and working on a GENI project about the streaming. And another lab that is connected is the WINGS lab, which is Suman Banerjee's lab, and that he's doing wireless research, and you're going to see tomorrow and tonight, I think, in the demo session. And from their resources, they have GENI WineMax resources as well, so that these are a wireless site for GENI. And they have also connected through the wireless, they have connected local communities. So they have people, they have a project working with ambulances where they are connecting through the GENI backbone. They have a project with providing internet connectivity to local buses. So they connected the local community through the wireless infrastructure they have. So this is within the net, within the campus, what's happening. And then going upstream, they get connection from the Moxie regional, and Moxie also has a GENI rack somewhere, I think it's from this side. And they go all the way through Moxie to Internet 2. So this is the Internet 2 port that the Wisconsin campus is coming in. And from here, they get to other GENI campuses. They get to the L2S network, which is the Internet 2 network. They get to ION to do dynamic configuration of the network. And this is how they basically go into the GENI platform. So I think Wisconsin is a very good example to show you exactly how a campus gets the resources, how do they connect their own resources, how do they get connected with other GENI sites. So now, if we move to an example, for example, of a regional of what's happening, you see CENI is a regional of California. So this is tomorrow, all the demos you're going to see happening in the evening demo, they all go through CENI. All the layer 2 connectivity to the GENI backbone go through the CENI regional. They do have their own GENI rack. So for example, if you wanted to put compute, if you needed computation within your slice in the middle of the network, you can get a slice in the CENI rack. And they do have multiple GENI-enabled OpenFlow switches that experimenters can have access to, so that they can run and manipulate the forwarding of their own traffic. And then you see, all the campuses that they are connecting and they're bringing into GENI. And in most of these campuses, there is also a GENI rack that connects. So you can imagine another whole Wisconsin inside of CENI. Now, for the research backbones, we have an ongoing partnership with the Internet 2, and they're implementing a national scale infrastructure. So the Internet 2 is sliced and deeply programmable. They used to have the ION service for campuses to be able to dynamically create circuits and connect on the layer 2 level. Now they move to what? Sorry. They moved to using AL2S, which is a pure OpenFlow network. So it is by definition sliceable and deeply programmable, and they provide high-speed connectivity to the GENI campuses. Internet 2 provides dynamic provisioning of networking. So, for example, if you have resources from 2 different GENI campuses, you want to bring them together, you go to Internet 2 and say, please provision a lane from here to here, and they will do this dynamically. So there's no, they're not only relying on statically provisioned networks, they also do this dynamic. And and right now there is an in-progress migration moving from the prototype GENI we had on ION to AL2S, which is their production system, and they are testing both dynamic provisioning through AL2S, so that we can actually connect these resources like we do now with ION. And they are testing how they can give access to their OpenFlow switches, which are their production OpenFlow switches, also for experimenters to run the network on the same infrastructure, how we can safely serve that without jeopardizing their production network. They are going to talk about it in the GENI operations session, which is tomorrow at 1:30. So they're going to talk about both these issues and monitoring and other stuff. Now, I talked about the wireless resources. So the GENI WiMAX, there is, first of all, there's an agreement with Sprint about which frequencies the campuses are allowed to use. They have tested emergency evacuation procedures in case they're experimenting around some frequencies that are actually used by Sprint or other network providers. And so this gives access to all the GENI campuses within a campus for people to run their own wireless experiment. And this is the agreement that I talked about before, where there is a project called SciByNet, and the PIs is Tim Martin out of Clemson and Ivan Setzner out of Rutgers, that they have their own mobile virtual network operator. So, and you're going to see demos about this tomorrow on plenary, where you can have, if you're an experimenter, you can have your wireless devices, you are connected to GENI WiMAX whenever this is available. If you go out of range of the GENI wireless, you can get roaming to the screen, and this whole process is completely transparent to the user. There is a session tomorrow, the WiMAX developer session, that they're going to be talking about this, and they're going to also be talking about how they integrate it with the rest of the GENI resources. Now, this is the map that only has WiMAX, because the previous map with all the GENI rack was a little bit overwhelming to see. These are all the places. There are 20 6 WiMAX base stations with 13 distinct sites. There are 90 Android handsets that they have sent out to the sites for people to do experiments. You get to see some of them both today. If you go to the booth of Sci-Net, they will have, they will have this Android handsets, you can look at them and play with them. And they also have these yellow nodes that I described before that have both Wi-Fi, WiMAX antennas so that people can run experiments, but they're not mobile. They're not mobile. They're statically mounted in the labs of the universities. They're also working towards providing a uniform experimenter experience using these yellow nodes. So, as you can imagine, running wireless experiments remotely is a very big challenge. How do you give access? How do you give access to the wireless infrastructure of a completely different university that is far? So they're really working hard on how to actually make that happen. And they do have, they also connect to the internet to backbone. So all these wireless sites that are here are all interconnected. So you can imagine you can run an experiment with some wireless nodes here, some wireless nodes here, and connect them through the layer 2 backbone. If you go today to the demo session, there is a demo out of Rutgers of Alpha Mobility First team. I'm going to talk a little bit more later also about Mobility First, where they basically have deployed, it's a new internet infrastructure, and they have deployed the routers in multiple of the sites, and they are using the wireless nodes in order to run their experiments. Now, I mentioned before that GENI is basically a federation. All the resources are administered by the local campuses. There is no one giant administrator for all of the GENI network, but we still need a more central monitoring system, even though it is distributed, especially since you allow people to run experimental software and not actually production. You need someone that is able to monitor the big picture and is able to find problems that only show up when you look at the whole of the GENI network. So we have like a GENI Meta Operations Center, which is out of Indiana University. They are the basic that they keep track of outlets across all the GENI campuses. So if you're an experimenter and you need to know which campuses are up, which campuses are down, where their available resources are. For example, this week NYU was in maintenance, and then 2 days ago, a tornado struck Wisconsin, and they were out. So you need a central place to go and look up to see which resources are up and which resources are down. They have a notification system for resource reservation. So if, for example, you want either a very large portion of the GENI network, or you believe that your experiment, running experimental software might be disruptive to other people, you want probably to notify the testing operators, and they have a notification system that the users can use. They are monitoring, they're constantly monitoring all the GENI aggregates, and again, they're going to talk about it in the tomorrow's operation session. They are also responsible for coordinating LLM requests and also handling emergency stop. They have tested both of these procedures. Emergency stop is really important because if you have, for example, a slice that for whatever reason goes, does something that is not good for the network, it might bring like the internet to the whole internet down. You need to be able to very quickly find who is responsible for the slice and very quickly shut down any traffic you're sending. And CMOP is responsible for handling these type of emergency stop requests from administrators of the different sites. There is a Google Calendar which will keep track of reservations and of outages for people that are running, that are using the GENI network. Now I've talked about the GENI racks, so let me be a little bit more specific. Again, GENI is about enabling production equipment. So we started with two major efforts, one out of IBM, and which was a collaboration with Metric, and they have what we call the ExoGENI racks, where they have more resources per rack, but there are fewer racks out there. And another one from out of HP, out of the HP labs, where they had, and it's in collaboration with the University with Rob Ritchie, where they have fewer resources per rack, but there are many more out there. There is a third type of rack. There is a Dell rack that's just coming out. Currently, there are only two racks. One is in Clemson, the other is at the GENI project office. And this is a collaboration between Dell and Clemson, and they are just, I think right now they're in provisional state. They're moving slowly to become production as well. So this is the third option that is coming out. So this was all that everything I have to say about how do we build GENI. So if you have any questions about that, since I'm going to completely switch topics, Any questions? No? Okay. I'll move forward. So the next thing I'm going to talk about is the actual usage of GENI. How are people using GENI, both in order to run experiments and as an educational tool in their classrooms. So there are two major threads about people using GENI. The one is, as I said, is for research. The other is for education. There are people using it in order to build, non-IP compliant network architectures. They're using it to do software-defined networking research. They're using it to evaluate large-scale protocols, and also they're using it to do cloud research or distributed systems research, because you can imagine that each one of these racks is just basically you build a large distributed cloud. In education, there are people that are doing classes in computer networking, in distributed systems, in wireless, cloud computing, and they're using it in all levels. So there are people that are doing undergrad classes, people that are doing graduate classes in GENI. And tomorrow, I'm going to talk a little bit later, but also tomorrow, I think in the morning after the plenary, there is a session about the people that are building modules for GENI for classes. On GENI, they're going to be presenting what they have. As of 2014, now, when we just check the numbers, we are over 2,300 users. So GENI usage is expanding very fast. Our user base is expanding. It's growing very quickly, and we're trying to keep up with adding more resources all the time. So I'll give some more specific examples about the kind of research people are doing in GENI. So these are the future internet architecture teams. It was a major funding effort out of NSF that funded multiple projects in order to try and imagine and build the internet of the future, how it would look like. One of them is the named data network. For those of you that were here yesterday, you actually go around. One of the tutorials was using their software running in GENI. Then there is the mobility first team that is out of Rutgers, which is the demo that I talked about before, where their basic idea is that everything is mobile, everything is wireless. This should be the center of our architecture design. That there is no unique attachment points for any device I have. And they are going to be doing it then both at the plenary and at the evening demonstration today. The other one is the XIA team, which is out of CMU, the PI is Peter Stinkstead, and it's about expressive internet architectures. Their idea is basically that we don't know how the future of the internet would look like, so we better come up with an architecture that can support any type of applications that might come up in the future, any type of usage of the network that they might come up in the future. And all of these three teams have been running their experiments on GENI, and they have been having slices on GENI. And GENI is the only tester that can support these teams, because each one of these teams, they have their own custom routing that they need to run, their own custom forwarding. So they need a place where they can actually do deeply programmable routing in the middle of the network. There are many people that are doing software-defined networking research. Here I just have two examples. One is the Prasad Kalyan of the University of Missouri, where they are doing the desktop cloud. There is a demo tonight, I believe. And for those of you, I don't know how many of you are going to the US Ignite Summit that follows the GEC, they will also have a demo there. So their basic idea is that everyone is moving towards, like handheld devices, which they are not very powerful, and they are moving any computation products in the cloud. But the quality of experience you have as the end user when all your data is in the cloud depends a lot about what type of devices you're using. So a cell phone with a much smaller screen has very different requirements. For example, a large screen, right? So what they're trying to do is take advantage of the deprogrammability of GENI in order to make smart decisions and provide the experience of the end user that is proportional to what type of device they have and what type of requirements they have. They have, this is the deployment in one of the experiments they have. They were running things in the GENI backbone, in the OpenFlow suite, in Internet 2, and in several campuses. And they just try to test this idea of how can we improve quality of experience for the end user. Another software-defined project is about how you can improve the performance of application. Uses what they call software-defined exchange points. They did a demo at the last GEC. They have like a weathercasting application about the emergency type of situation like tornadoes, tsunamis and stuff. They're trying to predict them very fast to notify the local communities. And they were using the software, they were using 5, I think, different software-defined software SDN domains in GENI, and they interconnected them in 2 big SDX. One was at the SOX in Atlanta, and the other was in Starlight in Chicago, and they did the experiment there. Now, I talked a little bit about the GEC20. So GEC20, after GEC, they have like a summit following up. So what is GEC20? Basically, GEC20 is trying to assume that we will have these networks like GENI, that they're like high bandwidth, deeply programmable, and try and see what type of new applications we can build on top of this type of networks that will benefit the local communities. So GENI is providing the infrastructure, and the computer scientists and the GEC20 are trying to build the applications of the future and actually bring them to the local communities in the cities. And if you are staying for the GEC20, I'm pretty sure you'll see many interesting demos of what we've done so far there. Now, I talked about being, GENI is being used in the classroom. This is, how we're progressively, more and more people are using it. In the last semester, we had like at least 15 classes, and this is the ones we know of, because not everyone notifies us when they're using GENI. This is just the ones that we've heard about. And there are 3 in solicitation for in the current GENI project that's going on for another year. We have 3 major projects. One is out of UMass Amherst. Jim Burrows and Mike Zinn, they are moving the labs of famous book to GENI so that people can actually use GENI in order to run these lab exercises. There is one out of North Carolina University where they're building modules on GENI, both to basically solve basic networking concepts. For example, how TCP behaves, the software behavior, how does it pass off, how does it share the link, and these are just demo modules that the instructors can just run in the classroom with students, and they also have example assignments that an educator can actually give to their student as an assignment about, and they have solutions and all the labs are running in GENI. There is also another effort out of the NYU, the New York University, which is about massive online open courses. They basically will use GENI as their infrastructure in order to offer this type of courses. They already have multiple modules there, and all 3 things they're going to be presenting in tomorrow's session. I think it's after the plenary. I think it's 11:30 to 12:30. It's an hour session, and they're going to be presenting all the progress they've made so far. So now, GENI upcoming events. We have a GENI tutorial at the SIGCOM coming up in August, so if you're there, just go by and check the tutorial if you want. And there is also the first workshop that is co-located with ICP, which is about speaking the networking research happening on testbeds. The emphasis on testbed doesn't only have to be GENI, any type of testbed. The abstract deadline is coming up. It's on July 6th, and the submission is July 10th. So if you have something related to that, you may consider some meeting to that. There are also, many upcoming GENI events. So we have almost immediately after the GEC, there is a collaboration between the European project, the corresponding European project like GENI, which is FIRE, and GENI, where they're bringing experimenters from Europe and from the US to collaborate and see how can they take advantage of this international testbed that's being federated. There is the GENI Summer Camp, which is in Iowa in the end of July. This is a very good way for students, NDAs and professors, like it's a crash course on GENI. We're there for 5 days. There's like 2.5 days of tutorials and presentations, and then in the last 2.5 days, the students get to do their own project with GENI. So they get to actually use everything there to help them. So this is very useful for new students coming up to speed about doing the research in GENI, and for teaching assistants that they're going to be helping there in the fall to be up to speed with GENI, so that they're able to help with that. That we have before every semester, for the same reason we do web seminars for teaching assistants and professors that they are planning to use GENI in the coming semester. We're going to be offering it again this fall, just before the fall semester starts. And of course, it's the next GEC coming up, which is in the end of October, and it's right before the workshop on ICMP. So we'll go directly from the GEC to ICMP, and it's in Bloomington, Indiana. So what's next for GENI? So, we're building GENI, people are using it, where are we going? Where are we moving towards to? So we have like big GENI campus expansion. There is a large waiting list, so in this map you can see, it's hard to tell the difference, but this shows all the campuses that we actually have funding to place GENI racks, and the yellow ones is the one that want the GENI rack, but we haven't identified funding for them yet. And there are people that also, GENI enabling their campuses on their own. GENI enabling usually means OpenFlow, probably a GENI rack being placed somewhere there. Some campuses that have like, they also get Wi-Fi space stations. If you're interested in buying a GENI rack, then talk either to the rack vendor or to the technical person. Tell you details about how you can acquire a GENI rack for your campus. Looking forward, so there is a solicitation for project that started a year ago, and there's basically there are like 4 major tasks. One is about building sophisticated tools to support complex experiments. As the GENI testbed is growing, we have more and more complex experiments that are being run, and we need better tooling. Reserving 1 PM by 1 PM and associating into it to configure it is not going to scale for people that want to do large experiments. We're expanding the class community of GENI. There is a lot of interest, so we're trying to help out by building modules. We also have like many what we call shakedown experiments. So there's I don't remember the number, but it's in the order of like 10 different research teams that they are trying to deploy the research in GENI and actually try to stress test the capabilities of GENI. So we have experimenters that are trying, for example, to do large-scale wide area deployment. They're trying to test the dynamic configuration of the GENI network. We have people that are doing software-defined networking and trying to use big portions of the GENI network. There are people that are trying to use GENI in other domains, the ones that GENI was not envisioned to originally support, like genomics or weather forecasting or anything like that. Science, and we just want to see, where do we break, what are the breaking points in GENI, how we can improve it. There is also discussions happening about how do we transition the GENI governance to the community. I think they're also going to talk about this in the GENI operations. And these are basically the 4 major thrusts that we're currently working on. And there are sessions in all of these things. So there is an upcoming tool session in the last day on Tuesday morning. There is an education session, I talked about this before. We have an experimenter developer roundtable where people that are running experiments in GENI get to give feedback to the developers and actually, have a conversation about what is working, what is not working, how we can make things better. And there will be sessions that are going to talk about the transition into the community. GENI, of course, is not the only testbed in the world that is envisioned to support networking research. There are many efforts happening around the globe. We are working actively with, I think, with all of them. Like, I think any country that is building a nationwide testbed, we are in contact with, and we are trying to federate and make sure we have common APIs so that we can at some point federate and build a global testbed where people can get resources across countries. Okay. Yes. Okay, so now I'm going to go and talk a little bit about how we actually use GENI, because this was all a big overview. So I'm going to actually go and talk about terminology of GENI and actually do a demo. So if you have any questions about the big picture of GENI, come to ask.
Could you please provide some more examples as to how domain scientists are currently using GENI? You mentioned it's being used in analytics. I'm especially interested in how you can use GENI nodes or GENI network in clinical testing.
So the project, what they're doing GENI as a big computation power. So they're taking big resources from different GENI labs and they're just outsourcing their computation. If you want to do clinical research, it becomes a little bit more tricky because suddenly it comes to privacy issues, as Martin very well knows, and then it's being more tricky because we don't have privacy. So people who want to do this type of experiments, it's more tricky. Other type of people that have used it, for example, recent collaboration between Wisconsin and Oklahoma, where they're trying to do remote surgery, and they're basically using GENI as a fast network to connect with different resources, and they have surgeon on one training, doctors on the other end, and there is another one which is out of, there is Marvin's, which they're doing also video, video surgery, right?
Right. I was thinking that what we would like, and what I think can eventually be done, is to encrypt slices.
Yes.
So if you wrote the stuff for the genomes to decrypt the slices locally, and hand the information off to secure computers locally, and then encrypt the slice when you need it to provide this.
Yeah, that's true. Yes, that's definitely something. You have something outside of this in mind?
I'm just looking at opportunities.
Opportunities, yeah. And tonight at the demo night is a demo out of Renzi, but they're going to be presenting. They're not. I don't know if they're going to be presenting Virgin Markets research, and they're going to be presenting it together. But you can talk to them because they're doing. Okay. Any other questions before I dive into all the GENI terminology? Before I lose you in the. No. Okay. There we go. Terms and definition. So I talked about the GENI is a sliceable network. So of course, every experimenter gets what we call a slice. A slice, if you think, when you start doing tutorials, you realize slice is just an abstraction. It doesn't contain anything when you create it. It's just an empty thing. It's an empty bag, but then you can start collecting resources and putting them there. So slice is just an abstraction where you are slowly starting to create this slicing of the network by adding compute resources and networking resources and connecting them together. They're meant to isolate experiments and traffic from one experiment, so you can load another experiment, so you can use GENI at the same time, and the experimenters are responsible for the wrong slices. So there is this, remember before where I talked that if something really, really goes wrong, Timo will actually shut down the slice, and then they're going to track down the experimenter, and they're going to be talking about what went wrong. So the person that is finally responsible about what is running in a slice is the experimenter. Right? It's not the resource provider. They're not the campuses that are giving the resource to the experimenters. So how this whole trust thing works. So I've talked about GENI being a federation. I've talked about how the campuses are giving resources to the GENI community and how experimenters get to use them. But how is the whole trusting issue happens? Like, can anyone go and get resources from GENI? How does this happen? So, assuming you're a researcher and what you want to do is get a slice on GENI, and you basically want to go into someone else's campus and go into their own GENI lab and get some resources there, and then you want to go to Internet 2 and say, "Can please give me part of your network?" How does this work? So the researcher is registered with a clearinghouse, what we call a clearinghouse, which is basically just an authentication place. You go and you say, "This is who I am. Please allow me to use GENI," and that is where you go and create your slices. So the main thing where authentication authorization happens is in this step when you're talking to the clearinghouse and you say, "Please allow me to use GENI," and that will give you back a slice credential. So all experiments in GENI run in slices. So the main thing you need in order to go and ask for resources is a slice, which is this abstraction and empty bag. So you go, you say, "Who I am, this is my email, whatever." We know that you're allowed to use GENI, and we give you back what is called the slice credential. And this is then what you're going to go and present to the different places where there are resources. The places where there are resources, they're called aggregate managers. So you have the physical resources, a rack, a network, a switch. And in front of that, there is a piece of software that's called an aggregate manager, that basically handles, that basically manages all the resources that are behind and makes sure that only authenticated users get access to the resources. So the researcher is going to provide the slice credential to the software here, it's called an aggregate manager. It's going to describe what type of resources it wants, and the aggregate manager will verify that this user is allowed to use GENI. It's going to go provision some resources and give them back. So there is not only GENI again, it's federation. There is not only one clearinghouse in GENI. One of them is out of the GENI project office, but MULab is another clearinghouse, PlanetLab is another clearinghouse. In Europe, there are other federated clearinghouses. So you go to any of the federated clearinghouses in GENI, you get the slice, and then you go and get the resources. Now, what do we do with user authentication? So the clearinghouse that is run out of the GENI project office is federated with InCommon, and basically InCommon is a big research. It's basically, yes, I think it's mostly for research institutions where there's like a federation where they outsource authentication to the local university. So for example, if you want to use some resources in NYU and you have a Stanford account, the library is usually use that, then you can log in with your Stanford credential to an NYU library and you have books from there. The same thing happens in GENI. You use your local authentication mechanism with your local US university, and that will log you into GENI and will give you an account. I don't know how many of you had this opportunity, but when you go to log into the GENI portal, you can choose your own institution there on the list. And so basically, we're outsourcing the authentication of the users to the local universities. If you're a member of a university, you automatically have access to GENI. For the universities that are not yet federated with InCommon, the GENI project office does run a federated identity provider. So for those of you that, if you're not a member of an institution that is federated with InCommon, you get a GENI account through the GENI project office, and that only gives you access to GENI. But you're federated again through InCommon. So this is how we deal with GENI user authentication. There is not one central place that we keep track of all the users. We just outsource the user authentication to the local universities. Now, another very awesome term, which is sliver. So now you're going to be wondering what the difference between a sliver and slice. So you can think of a sliver as a part of your slice. So a sliver is a small part of your slice, and sliver is what actually is the resources. So for example, FBM, like FBM is an actual sliver. A piece of network is an actual sliver. So all those slices and abstraction and it's empty, sliver is what actually has resources in it, or not in it, it is the actual resources. And that's why a slice is comprised from many slivers, because you can have VMs, you can have flow space, you can have networking. Okay, so you can imagine, here are all the aggregate providers, this is your slice, and wherever your slice intersects with the providers, those are your slivers.
Is there any difference between a resource and a sliver?
Very good question, and it depends on the aggregate manager. So it depends on how much they want to, in what granularity they want to treat the resources. So for example, there are aggregate managers where all your resources, like 5 VMs and your networking and all the LANs, are one sliver. For other people, they treat 1 VM, 1 sliver, so it depends on how the aggregate manager wants to treat the resources. But it's the smallest piece of, a sliver is the smallest piece of thing that you can act on at an aggregate. How the aggregate decide to split that is up to them. Now, we have RSpec, so we said that the researcher needs to talk to the aggregate manager and ask for stuff. How do we ask for stuff? We ask using RSpecs, which is basically, in the end of the day, it's just an XML document. But it's basically the machine language of GENI. It's what describes topology, what describes resources. And what type of RSpecs do we have? So here is you, the experimenter, hopefully with the tool in front of you. You don't have to craft your own RSpecs. And here is the aggregate manager that manages resources. The first thing you want to do is go and say to the aggregate, tell me what type of resources you have. Describe. Do you have VMs? How many of them? Do you have raw PCs? Do you have networking? And you get back what we call an advertisement RSpec. This is the first type of RSpec in GENI, which basically describes resources that an aggregate manager has to give to the experimenter. Then the experimenter looks at the RSpec, hopefully the tool does this for the experimenter, and says, okay, out of all the things you have, I want something very specifically. I want these 3 VMs connected in this topology. And this is what we call the request aspect. So this is something that the experimenter sends to the aggregate manager describing the topology they want in this specific aggregate. Now, the aggregate manager actually replies back and says, okay, you want this, and this is what I gave you, with exact. So for example, in the request aspect, you might say, I want 1 VM. The manifest that will come back will tell you, yes, I gave you one VM, and this is the IP address of your control plane, and this is the IP address of your interface, and this is how much memory it has, and whatever else information. So it will make it more concrete. And this is what we call the manifest aspect. So there is the advertisement aspect that comes from the aggregate manager advertising the resources. We have the request aspect that the experimenters are using to request stuff. And then there is the manifest aspect that you get in order to describe what you actually have. You get your manifest not only when you create your sleepers, but you can get your manifest anytime. So if you forget what you have in a specific aggregate, you can ask the aggregate keeps track of this for you, it will give you back the manifest aspect again. Okay, so now, yeah, we won't have real time for the demo, but I'm just going to go through it very quickly. And actually, we have 10 minutes. Let me try and do it very fast. So I'll try and put all these things, aggregates, slices, sleepers, all together. So, okay. Okay, so this is the GENI portal. I have already logged into it. So I used my GPU account in order to log into the GENI portal. And I'm going to go to this, GEC20 project, and I'm going to create the slides. So basically, I'm going to authenticate again. So now you get to see the income federation. Here is a list of all the universities. So for example, if I start saying, here you see all the, Boston University, Boston College. So if you start typing the name of the university, you'll see here, and you can go and log in with that. And GENI Project Office is one of the identity providers where I have an account with. And then you see that I was redirected to the GENI Project Office webpage. If I use a different identity provider, so if I chose Boston University and click continue, that will automatically transfer me to the Boston College. That will take me to the Boston College website in order to authenticate. Okay? So this is how the income federation works. Okay, so now I'm back here and I want to create a new slide, so I will go to the clearinghouse of the GPO and I will say, please give me slides so that I can go and ask for actual resources. Okay, so now I created my slice. My slice is completely empty. There is nothing there, and there are all the actions that I can do. I'm going to use a graphical tool to parse my aspect, to parse the manifest aspect. This tool is called FLAG, and hopefully the data will work. It seems like we were having some problems. Okay. As some of you know that you were here, for whatever reason from this network, we cannot use Chrome to launch FLAG. We can use Firefox. No idea why. Okay. Now I have already created my slide, so I'll go here in my slices and find it, and I can launch FLAG here. And FLAG is just a graphical interface. It's the tool that stands between the experimenter and the aggregate manager. Okay, great. And it's the one that will help you parse the advertisement aspects. It will help you craft request aspect, and it is going to read the manifest aspect and give back to you relevant information. So this, unfortunately, I cannot make FLAG bigger. So I know that this is hard to see, but I'm trying to point things that everyone can see. So you see, these are all the aggregate managers that are in GENI. GENI is indeed the federation. These are all the people that are providing, and this is just a subset of them. Not everyone is here. These are only the aggregate manager that flags understand their advertisement aspects and can do something intelligent with them. There are other ones that they don't understand and they don't show up here. And you see that flag, the first thing it does is it goes out to each one of the aggregates and it asks what they have. So this is the step that failed for us yesterday, and basically we believe that the reason why is because flag is going and blasting all these people on the same port asking for resources and somewhere in the wireless networks, they'll probably start blocking the port because they think we're launching a DDoS or something. So if this is successful, which I don't know if it's going to be, because yesterday we were having problems with the wireless networks, here you're going to see all the resources that every AM has. They're going to appear in the second column, and it's going to tell you what they have, if they have LANs, VMs, raw PCs, and then once this happens, then we can go and draw our topology. So what's happening now is that flag goes in each one of these aggregates, and oh great, we start seeing the reds. And it is trying to get back the advertisement RSpec. So okay, some of them failed, some of them are back, and now you see that it parsed the advertisement RSpec, it goes back, and you see here there are VMs, there are PCs, and I can go and draw my topology. So I can go and get, for example, to the end, I can draw a link between them, and I can go and modify. If I go here, for example, I can select a specific image. I can decide what image I want to install on my node. I can decide what software to run on my node, and stuff like that, and then I can press submit. And that will, now what's happened is that the flag, by the topology I drew here, it went on the back and it created this request RSpec, which I'm going to show you in just a bit. It crafted the request RSpec and sent it to the specific AM, which is an Insta GENI rack in the Max regional. And it's now waiting for the AM to reply back to see whether I got the resources or not, whether there were enough resources. I just asked for 2 VMs, so this should be fairly fast. And let me. Oh, and I cannot make this. I cannot make it bigger, so, and it doesn't really matter because it's an XML document, and hopefully you won't have to see these things too many times. I'm not going to say that you will never see an RSpec in your life. That would be a lie. But hopefully, you're going to see RSpec very few times in your life. So you're going to see here that there is one node here, there is one node here, and this is the one link between them, and that's basically what this whole RSpec says. And then there's a lot of stuff that are very flat and specific. Okay, so basically this is an XML document that the flag created for me, and then it goes, and now we're waiting to get the status of our resources. And when the background turns green, it means that my resources are ready. They're provisioned and they're ready for me to log in. This step usually takes a while, and the main reason is because these are actual resources, they're actual VMs. So the aggregate manager has to go and load the OS, download any software I asked for it, install it on the nodes, configure the nodes before it can come back to me and says, now you're ready, you can use your resources. So this step usually takes a while. And then you're going to see that once this is completed, it's also going to give me the IP address and all the login information I need in order to access these VMs. I think we might be running out of time because I know there's a lightning talks right after, so I shouldn't run over. But let me finish with the presentation, and then I'll come back and see what are those slides. Okay. Oh. I can start from the beginning if anyone hears it all over again. Okay. So, I've done all this. I have a server, I have a client. This is how, hopefully, if it all works, this is how my slides will look at the end. Flag will turn green, and the individual resources are all green. And you see here, they're the login information. So I ask for a VM, and this actually tells me which VM server has my VM and what is the port that I should use to SSH. And if I go to the specific information, I will see how much bandwidth my links have, what username I should use to log into the resources, what is the MAC address of the interfaces. It has all type of information for the VMs. So that, now on the wiki, there are tutorials that you can take by yourself. There is also tutorials offered at the GEC, and let me very quickly go to the agenda, because I think this is more important. So I know you cannot see the agenda, so again, I'm going to talk about very big things. So the coloring of the agenda, what it means, everything that is in this reddish pink color is of general interest. It's for anyone. The green sessions are mostly experimenter focused, so they're mostly tutorials for people that want to get hands-on experience on how to use GENI. This purple blue is for operators. So there is 2 training sessions for operators at this GEC, and then there is the operation sessions here, and then there is this orange that is for GENI developers. So this is where the developers meet and they talk about whatever problems they're having and how they're moving forward with the GENI deployment. If this is your first GEC, if you're interested in a topic, you can stop by and see. But usually these sessions are very nitty-gritty details, so you might get lost in whatever terminology they're using. They're very interesting. I'm just saying that if it's your first GEC, it might be an overwhelm to go to one of these sessions. And then there's this other color, which is basically, I don't know, dark green or whatever, which is basically for developers and experimenters. One of them is a roundtable where experimenters and developers get to talk. And the other one is the upcoming experimenter tools, where developers get to present what they're doing to experimenters, what tools are coming out. Wherever you see a laptop, that means that there is a hands-on tutorial. You will need a computer in order to be able to participate in the hands-on portion of the tutorial. The green dot is what we recommend for newcomers. So if this is your first GEC, we try to choose one session at every time slot of what we suggest. You should go to. You can choose anything you want, but this is just our suggestion. And at this GEC, for the first time, we try to have a theme. So this time the theme is systematic experimentation. We see too many of our experimenters struggling with trying to run complex experiments. So we wanted to emphasize and try and teach people how to have better chances of succeeding when they want to run a complex topology, what steps they should follow. All the sessions that you see that they're involved, they're part of the theme, with the main one being the tutorial on systematic experimentation in GENI, where we'll have multiple developers giving advice and giving examples about how to best build a complex experiment. And then at the experimenter drop-in that follows the session, you will actually get hands-on experience in small groups with the developers trying to use the tools that they're going to present. So for example, how do you create your custom image for a GENI node? How do you write your automated install script so that your computer comes up and is already configured for you to use? These type of tools they're going to be talking and teaching here. Okay, any questions on the agenda? Cool. Okay, the next GEC is going to be in Indiana. I said that before, in every GEC there's planning and discussion sessions, there's tutorials and workshops, and there is driver grants for US academics. And especially, if you know people that they haven't been to a GEC and they want, there is funding opportunity for them to attend the GEC. And now let's go back and see what happened to our slides. Okay, it still hasn't come up. It should have come up by now, but at least you get to see a screenshot of what it would look like when it comes up. Any questions?
My question was to this, when we by the donor to see how well
what I should improve next time I do the talk hour. Okay, I'll be around if you have more questions, but